Hello and welcome to Chapter 7, continuing here. I'm trying to get everything adjusted and it's kind of. There we go. Hi. Hi, y'all. This is the first time I'm using this feature that has been added to Apple's Keynote. It's also available in in PowerPoint, so you may see other people using it. Basically, it's taking my camera feed from my computer and feeding it to an image location that you can specify on your presentation slides and then talk over it. And then I'm recording me doing that. I can use it either in teaching my classes live or in creating a recording such as you're getting today. So picking up where we left off, we were talking previously about the use of the various predictors that we've created and the various ways that we use them to create a selection procedure. We talked about the multiple hurdles procedure, which is where you take the various things that you have come up with that you deem important, that you either have evidence for, have decided are important for making a hiring decision, and as a person clears each of those hurdles, having a sufficient degree, having a sufficient number of years of experience, having experience in a couple of two or three key areas, that kind of thing. As they clear each one of those, you look at the next one, clear degree, then you look at years of experience cleared, then you look at what the specific experiences were. Did they have two of the three that you thought were important? Then they proceed. If they only have one of the three or zero, you don't look at them any further. Two or three of the three, they go further, and you look at other factors, and eventually you decide who you're going to hire. Okay, well, that's definitely one way to do it, and it's a common way, and it's not a bad way at all, really. But there is another way, and it has a good bit of history of it being fairly common, and that is a regression approach. And the regression approach that can be used is a recognition that actually nothing should really be such a literal hurdle. That just because a person doesn't have a degree, that doesn't mean that their experience might not outweigh the specifics that a degree is believed to confirm. And so nothing should be sufficient to block hiring or entry into the situation. And to take that into account, an integrating equation is used. The integrating equation will have a characteristic like this, and I don't want you to freak out. We're not going to do like mathematical calculations in here. I'm giving you a feel for it. You might have to do a simple calculation, but it will be that simple, something you can do in your head or very easily. The equation would be something like y equals b subscripted 0 plus b subscripted 1 plus x subscripted 1 and so forth, to as many as you have items. That basically means that some factors might count more than others, and you can do that by the values that are attached to B. You make B's larger and the value of the contribution is higher. It also is a way of handling the fact that what you've measured about people might come in its own unique scale that is not really consistent with another scale. It may be that, if one of the factors is, say, GPA, that's on like a 5-point scale, and SAT is on a 1,000-point scale. Kind of hard to figure out exactly what you should be, how you combine those in a way that will actually equitably contribute them, or in a way that actually is useful. So this can help you with that. So B being a weighting factor for each of these is a way to handle both a problem that might come with the information you have, but also to take into account the fact that some things you genuinely might care about more, even if they're measured on a similar scale. So an X is the actual numerical value that you've obtained from the predictor, and this is used when you are able to make numerical values. Now, sometimes it may seem, well, I can't make numerical values of something like having a degree or not. In actuality, you can. 1 equals having a degree, and 0 equals not having a degree. And so you can make that a factor. You can weight it to be, say, 50%. And that means that if someone doesn't have a degree, they have to have a lot of everything else to still look like they're a viable candidate. And that's where we come to Y. Y is the predicted value of the criterion, and if it's high enough, the person can be given an offer. And that's really where the bottom line is. Do you have an offer to give? but just having an offer to give is good. You want to know if this regression approach is really working for you. So to do that, we're going to create an example to talk about, and let's see how it looks. We're going to be talking about maybe deciding who to admit to school, to a college, and we're going to make that decision based upon a prediction of what we think their first year GPA is. You don't want to bring someone to college who's basically setting them up for failure. You're going to end up taking their money and not actually having a successful outcome, and that has some genuine ethical issues. So you want to make sure that these students that you bring in have a high probability of being successful. So you have an equation that is predicting the first year GPA. And so that could be a -1 plus the high school GPA plus 0.001 of their SAT. The reason for that is SAT is such a numerically larger value that you want to take it into account. So Sam has a high school GPA of 3.3 with an SAT of 1,000. You apply the equation to it, and you're going to get a predicted GPA of 3.3. Let's walk through it a little bit. High school GPA, first thing we do is subtract 1 from it. Now it becomes 2.3, and then we add to that 1,000 divided by 0.00 or multiplied by 0.001, and that's really 1,000 divided by 1,000, and what you end up with is 1. See, the 1 you took away you add back because of the high SAT, and there you go, you got a 3.3 predicted for Sam, and 3.3 is probably a value you would accept. Sid has a high school GPA of 4 with an SAT of 800. We predict their first year GPA to be a little bit lower than their high school GPA because their SAT is not as strong. Still though, that high school GPA shows that Sid does know how to get their work done in a good manner. Joe has a high school GPA of 2.6 with an SAT of 1,300. That's pretty high SAT. And GPA is 2.6. Well, we would predict their first year GPA to be better than high school GPA at 2.6 because of that SAT at 2.9. But then we get into, well, where do we set the line for that? I mean, if we set the line that we want to predict someone has a 3.0 or better, then Joe does not get offered acceptance that Sid and Sam do. If, on the other hand, we have a lower mark, maybe it's 2.5, then all three would receive acceptance letters. Well, so we have various selection processes. How can we decide how accurate they were? Do the hires tend out to work and non-hires not work out? Which is kind of a weird concept. How do you determine if a non-hire doesn't work out? Well, there are ways to do it, but it is difficult. You identify an issue, but we can conceptualize about it and do some get some reasonable insight into what kind of thinking can be applied to get at usefulness. How good is this process? So this graph may look a little troubling, a little overly large, and a lot of stuff here, but let's talk through it. Along the x-axis is our predictor battery decision. It's basically the y value we get, okay? And it's telling us whether or not we have made a decision, what values could come about, and then the vertical line is where we make our decision. That is higher than that line, higher scores than what looks to be about 7 here, and we give a hiring decision. Lower than 7, we don't give a hiring decision to. Then the criteria is some determination of failure or success, whatever that may be. And if we have decided that someone is a success, then they're people that we have actually hired, then that's good. But if we didn't hire them and we find out later they went to a competitor and they were very successful there, then we go, wow, we should have hired them. That was a miss. We missed an opportunity to hire that person. If we hire some people and they don't work out, well, those are what we call false alarms. Our system said, ding, 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 hire them. That's what we mean by an alarm. Usually it means a bad thing, but in this case it means alert, do something. And they didn't work out. Well, oops, we've hired people and spent the money on hiring, training, and all the rest, and then we had to let them go. or they quit maybe. Sometimes people, if they're not doing well on a job, they often aren't very happy on it either, and they look for something else. But what we want is the green areas, the hits and the correct rejections to both be where the predominance of our decision making lands if we have a good, valid selection method. Correct rejections are hard to learn about though because they usually are things that we can't actually get any knowledge of. Maybe they go to a competitor and they end up, washing out at the competitor too. Then we have learned that. Then we know we dodged a potential problem there, and that's good. So, decision accuracy is one way we can determine if a process has good utility, good usefulness. That is done by a specific calculation. Decision accuracy is done by counting the people in each of the four quadrants and plugging them into some equations. So we can get what's called a decision accuracy for hires. That are people that are on the right-hand side of the vertical decision line. And that's going to be, you'll notice there's numbers, 1 in the upper right quadrant, a quarter of the picture, 2 in the lower left, 3 in the lower right, and 4 in the upper left. And so what we're doing is we're going to be using those numbers to describe our equation. And to get the decision accuracy for hires, we're only interested in people in quadrants 1 and quadrants 3. So quadrant 1 is divided by quadrant 1 plus quadrant 3. So we take only quadrant 1, put it in the numerator, and then take the denominator that's composed of quadrant 1 and quadrant 3. And the next slide is where you see what happens when I do some copying and pasting but have not fully integrated it into my animation system for the slide. The arrows are there, but they are reoriented properly as soon as we get to that point. Decision accuracy can also be done by you taking care of all applicants in the process. This is an overall decision accuracy decision. We're getting there. That is quadrant 1 plus quadrant 2. These are all of our correct decisions. The people we hired, we should have hired, they worked out, and the people we avoided hiring, that it's good we avoided hiring them. That is the total correct decisions divided by total applicants. And so of all four quadrants, quadrant 1 plus quadrant 2 divided by all four quadrants are the total number of applicants. And that enables us to get a sense of what our decision accuracy is for overall decision accuracy. And that's great, but that doesn't cover all of it. These calculations depend upon some things. Notice these vertical and horizontal lines, especially the vertical line. That's something we're picking, presumably based upon a research process that validated the decision decision process, the selection process, and we have a value there, and that value is critical to how accurate we can be. Let me show you something that's going to be a little counterintuitive. Imagine, this is my version of a similar graph as we were looking at earlier. Imagine we have a perfect selection method. Perfect defined as all of our decisions are right along an angled line through all of the data. That is, every individual falls perfectly on this line in a lockstep order. You can see the little X's, the little crosses there. And so we have 1, 2, 3, 4 hits. We have 1, 2, 3, 4, 5 correct rejections. We have nothing in the false alarms and nothing in the misses area. And this looks like, it's perfect. We're making perfect decisions. But that's only because we have the hiring line set, the purple vertical line set at 8. If we move it higher and put it at, say, 10 or 11, 10 and a half, then suddenly we have 2 misses, people we should have hired and did not. That's because we had our criteria set too high. Even with a perfect relationship, between our predictor battery and our criterion. Even with a perfect relationship, we can still misuse it in a sense by setting the decision point in a place where we don't get the optimal possibilities of decisions out of it. Similarly, it could be set too low and it could be down here like 4.5. And if it's at 4.5, then you end up with a decision that leaves us with a lot of hired persons who don't work out, who wash out working at the company for whatever reason. And this is not good either. There's a perfect relationship between the predictor and the criterion, but we're still making mistakes. And it's because this perfect relationship is only as useful as the decision point we have being set in the right location. And that's why getting hung up on getting a perfect correlation is not necessarily going to lead you to the best outcome. Getting that decision point, that decision vertical line, that decision value from the predictor system optimally set is really going to be where you should be putting your effort. So, why it matters? Well, because it allows us to make our best decisions. Going through this validation process allows us to see if our decision predictor decision point of, in this case, 7-ish, is a good point and is where it should be to optimally get the best overall decision accuracy and the best hiring decision accuracy. Well, that's not the whole story when it comes to making selection. We also have to get offers accepted. That is, accepting and keeping a job is important, and sometimes employees quickly quit the job or are quickly fired from the job. I quit a job after only a couple of weeks. I know other people who have done it. I decided that where I was working was really not good for my mental health. It was way too high a pressure compared to what it looked like going in. That didn't work for me. And sometimes you have people you hire that you have to let go of. The perception of a positive process with honestly delivered information about the job and organization helps with acceptance. I see my image has frozen. I don't know if that's what's actually recording. A flexible benefits plan is also attractive to gathering employees. That is, where someone can select from a range of benefits which ones that they work best for them. Someone who doesn't need child care, for instance, can not select that particular benefit and instead can opt for maybe a dental care plan. Flexible job duties is also attractive because it allows a person to kind of customize their job towards what they prefer. Making an offer. The realistic job preview, as we discussed in an earlier lesson, are good at presenting both a favorable and unfavorable aspects of the job. When some of you were recruited to FSU, there were opportunities to visit with existing students. And that was a chance for you to say, hey, what's the problems here? I hear it sometimes when I've been involved in recruiting visits by students that we'll occasionally hear parents or students ask about the weather here because it is harsher than it is in the eastern areas of the state. And letting students know how we handle it and that we have an intention of safety but also an intention of continuing our work is generally helpful. There's also legal aspects to our hiring process. There are what's referred to as protected classes of individuals that are going to be involved in our hiring process. These are people who, because of ethnicity, race, gender, and other factors, have historically been discriminated against. That is, there is a history and often still a overt or sometimes not obvious continuing of discrimination. And the goal is to ensure that persons who apply for a job have an equivalent chance of being hired regardless of their ethnicity, race, gender, or other factors, things that are not relevant to the job. There are occasionally things that are relevant to the job. We'll talk about that in a moment. Selection ratios then becomes the key thing. A selection ratio is actually a little bit complicated because it involves three total ratios. It's saying the proportion, that's a ratio, the proportion of people of the protected class offered the job is compared to the proportion of people offered the job in the non-protected class. And after that calculation is done, then a 4/5 rule is applied. That is, if it's less than 80% selection ratio for a protected class, that becomes what we refer to as prima facie evidence of adverse impact. Prima facie meaning on its face, you can see it, and a further investigation is therefore warranted. And that is, in fact, what happens then, because it could be that it was an accident of the situation and is not indicative of an overall history, that prior hiring and subsequent hiring has not had this issue go on, because sometimes the numbers just don't work out perfectly. Let me give you an example, because in this case, an example really makes a difference. We're hiring a truck driver, and this is traditionally a male occupation, and women are increasingly doing it. And we have a certain number of people applying. That's a key factor. You are not required to hire the same number of people, but you are required to have an approximately similar number of people offered the job based upon the number of who applied. This is where we get into there's three ratios calculated. And you're going to see them presented here. 200 males and 100 females, which are the protected class in this situation, applied. 80 of the males were offered the job, which is a ratio, a proportion of 40%. For females, 35 of the 100 were offered the job, which is 35%. Notice that there was not a requirement to offer 80 females the job, because that would be 80% of the females, and that has an inherent irrationality. If only 100 females were interested, then you can't expect the hiring to be more into the the number of applications as there were as it is from men. So you have 35%. Those are then compared, a ratio is created from the 40% and the 35%, which numerically are 0.35 and 0.40, and you divide the protected class ratio by the non-protected class ratio, and if it's above 80% or 0.80, then you don't have evidence of any kind of bias there. That doesn't mean bias wasn't happening, by the way. It simply means that the first thing we check doesn't show a problem. Another situation, same setup, truck driver hiring, and in this case, for some reason, this job was very attractive to women, and 300 women applied. We offered the job to 80 men and 80 women. On the surface, that looks like that is essentially fair. 80 people offered both, but you had a lot more women who applied, so you would expect more women to have been hired. The proportion selected for men was 40%, as it was in the earlier example. But it's only 27% here because so many more women applied. What you end up with, therefore, is a selection ratio of the 27% divided by the 40%, which ends up being 0.675 or 67.5%, and that is lower than the 80% 4/5 rule. And this would be prima facie evidence to do an examination of there being possibly some kind of discriminatory hiring behavior going on. So, if you have evidence of an adverse impact from that, then the company has to defend what happened. They go into a demonstration of their valid method of determining qualifications using KSAOs and other things, and they need to make sure that there was no proxy to ensure exclusion of members of a protected class. For instance, you might say, well, a college education is required. And as soon as you say that, any protected classes who have a lower percentage of people who get college educations become inherently excluded from applying successfully for the job. The reason for having some kind of exclusion, such as, say, college education, is that it is a bona fide qualification. That's what it's referred to. Must be a bona fide occupational qualification. By the way, if you're wondering why I'm pronouncing fide with the E pronounced, Latin you do pronounce your ending vowels like that, and that's the true proper pronunciation as I understand it, but most people say bona fide. If it is of bona fide reason for having that exclusion, then that's fine. But if it's not, then the company has to reform their practices and probably pay penalties to the individuals who suffered the adverse impact, that is, were not hired when they probably should have been. Well, what do we mean by a bona fide occupational qualification? Well, let's say that a company sells only men's clothes, and they can limit its search for models for their catalog or web pages to only men. This obviously makes sense. You sell men's clothes, you need people who present as men to be the models. In fact, now that I think about it, I need to change the slide so it doesn't say males as if it's the sex that qualifies, but the presentation as a man. And so I'm going to make an alteration in the future for this slide. I have to remember that. But the photographers, dressers, salespersons, other persons that are involved in this process of making the catalog or the web pages, they don't have to be males. They don't have to present as males. They can be female, non-binary. There's no restriction in that case. It may be increasingly argued that the exclusion, the bona fide exclusion criteria, is not the person must be presenting as a male, but the person must not present as a woman. I don't know where this is going. We are always involved in a changing landscape of where our cultural norms meet our legal requirements. And as we as a society evolve, both in the good ways and bad ways that we do, we hopefully will continue to have reflected in our practice and law the best aspects of how we aspire to be. So you do have to take care that some apparently reasonable requirements are not actually inappropriate barriers, that is, proxies for exclusion. You're requiring a college degree in this example. I'm pretty sure there's nothing in any of this that requires a college degree. Now, I do not work in the fashion industry. I don't really know anything about it. This is out of my imagination. But I have a hard time imagining the requirements for a college degree for any of the jobs that I'm looking at here. Do you maybe prefer a college degree for some of the folks, particularly maybe your web designers or your high technology people? That's a different story. But anything I've got listed on this page, I'm not sure I see it. Okay, so the next class is going to be Chapter 8. And I will have a recording up for it soon. Thank you so much. I hope you found this new way of doing a recording workable. Bye.